are the key characteristics of the ad hoc networks? Where it is used, what are the issues, then we compare the cellular versus ad hoc networks, and then the key areas of research actually in ad hoc are in routing. So after a brief introduction to why the routing is an issue, we talk about 3 of the well-known routing algorithms. Actually, again, just like TCP, there are hundreds of algorithms that have been proposed for ad hoc networks, but we talk about those 3 that have been actually selected for implementation by IETF. And so these are more real than many of the other proposals which are only theoretical. So these 3 are DSR, AODV, and OLSR as shown on the slide. So we'll talk about those 3. So first of all, what is an ad hoc network? Ad hoc network, we already know, is one in which there is no base station. So you can have a cell phone talk to another cell phone, or a computer talk to another computer, or a computer talk to many computers. So if you make a network out of all these different computers which are talking to each other, it makes a network. And not only a network, each of the computers is actually acting as also as a router. So when somebody from one end of the network wants to talk to somebody else at the other end of the network, they may not have a direct wireless link, and so they will go through these different computers and different nodes. And so obviously everybody has to be a router and has to know about the routing and connectivity, and so it's kind of tough problem. And the problem becomes, and some of these are actually the usual wireless issues such as power control, and in case of location, basically we need to find out who is where so that we can go through the route which is much more logical as opposed to just whoever can hear whoever. Alright, the 4th issue is energy conservation, which we already talked about. Energy conservation is basically the issue of battery life. Scalability. Sometimes these ad hoc networks can be very large. So where are the ad hoc networks used? Actually, one of the most common usage is in the military. In the military, if you have lots of soldiers, they could be talking to a cell tower, but if they talk to a cell tower, I'm sure that the enemy will first attack the cell tower, and therefore oftentimes they use radios that do not use any centralized facility, and so the ad hoc networks are much more suited for those environments, and there could be thousands of those nodes. And so the scalability is an issue. Security is an issue just like any other wireless, and then bandwidth constraint. So the congestion is a norm, basically because there are so many people trying to use the same link and same nodes. The congestion is they're generally highly overloaded. So all of this actually is very well described in RFC 2501, and this is just a summary of that RFC as to what is the issue of. By the way, there is a group in IETF called Manet actually, M-A-N-E-T, Mobile Ad Hoc Networks, and so Manet actually has produced many RFCs, and 2501 is one of the first ones. And more sensors which can be very critical, such as in the military and deployments. So anyway, so the whole, in the last several years, there has been quite a bit of research funded by NSF on sensor networks, and that has been a hot topic. So we will have a whole lecture on sensor networks next time, and in fact at the university we have probably several courses on sensor networks. So so we will talk more, but today at least we realize that the sensor networks are a type of ad hoc networks. I have listed here the top 10 issues because and the other one, which is more coordinated centralized access, is not possible in ad hoc networks. So most of the ad hoc networks generally use some variation of CSMA. The second issue then is routing. Now routing has the problem that we may not need. Suppose I collect all the routing information, and I continuously collect all the routing information. It may not be of any use because we are going to use it only once in a few bits transmission in an hour. So by the time I need it, either the information is either too old, or I have to just collect too much information just to transmit very few bits. So generally the choice is whether to do the routing when we really need it, or to do the routing before we need it. So if we do it when we need it, then the delay in finding the route or route actually is the route acquisition delay, which is an issue. And then quick reconfiguration is the issue that if somebody moves out, which people do because these are all mobile nodes, we have to be able to take care of that very fast. And loop free. And it's just like any other routing issue. We don't want to be going around in a loop, otherwise the message will never get out. And so we really need a bigger picture of the whole network to ensure that there are no loops. Then there is a lot of research in multicasting, and multicasting is actually very common in ad hoc networks, because whenever we want to send some key piece of information to all the soldiers or emergency situation, we really need to multicast that. And so while the multicasting comes very naturally and very cheap in a centralized network like WiMAX, it is very resource consuming in the case of ad hoc networks. Transport layer. So all the issues, the wireless TCP are still here. In addition, basically the frequent path breaks. The issue is that people are moving in and out, so the packets may really get out of order and get lost, and all those issues are there. Quality of service. Now, how do you really do any video or anything that requires guarantees in this situation where we really have so much dynamics? It's much more difficult than, quality of service has not been solved even in the wired networks, let alone in wireless, and then let alone in ad hoc networks, which are kind of difficult case of wireless networks. Self-organization. We talked about that. Basically, the issue is that to find out who your neighbors are, and then who their neighbors are, and so on. So really the whole neighborhood discovery. And then if you have discovered something and something changes, then again trying to find out, trying to propagate that information that the link has failed. Seventh issue is security. Denial of service. Somebody can jam the whole area. Energy depletion, batteries running out on several nodes. So, and then comes the issue of energy management. How much power will be using? How much, and the battery has to be carefully monitored. But also the question is, if transmission power is one and the processing power is another, because processors also take battery. So when we do routing and all that, we have to be worrying about as to how much energy we are using for routing, both radio transmission as well as for routing computation. Addressing and service discovery. So basically, do we need global addressing, and how do we find out different nodes? So there have been some proposals on different types of addressing for ad hoc networks. And then the pricing scheme, incentives are relaying. So one of the actually failures of ad hoc networks has been that we have not been able to use it in the real world other than military world. So for example, there was a dream a few years ago that one could have a service where one home could subscribe, for example, to DSL service, and then the whole neighborhood could basically share it with another ad hoc network. Or one could subscribe to a wireless link, and then the whole neighborhood could really get it from them by relaying by different houses. But the issue is, why would somebody want to relay the traffic to somebody else? And the networking and everything else talked about. So the mobile stations are rather complex with ad hoc networks. No forwarding fairness issue. So One of the issues in ad hoc networks is that how much energy and time and resources you devote to forwarding other people's traffic versus your own traffic. When you have the load which is close to 100%, should you just be having 90% of it for yourself, or should you have 50% of it for yourself, or should you have 10% of it for yourself, because there are 9 other people sharing the same thing through your network, to your node. So there is a whole issue of fairness which doesn't exist in case of cellular networks. I mean, cellular networks, the fairness is rather simple, where you want to make sure everybody who has the similar traffic gets the same kind of throughput, which is much more easier than worrying about whether we transmit or forward. Then the issue of time sync, because everybody can synchronize to the base station, we can very easily use TDMA, time division multiple access. Remember, in time division multiple access, if 2 different nodes basically need to transmit, they have to take their time slot, and they have to know exactly where the time slot begins and where the time slot ends, so that they don't run over into each other's time. So TDMA requires time synchronization, which is possible in a cellular network, or easy in a cellular network. In a ad hoc network, is very difficult. Is idle, but it cannot really hear the transmission from A, and so network may not be idle. So one has to use something more than carrier sense. And does anybody remember what did we use in 11 along with CSMA to ensure that we get the medium when we need it? There are 2 extra packets that we send. Okay, so diffs and sifs had to do with the issue of how long to wait before somebody else. So that is one good thing, yeah. But the thing is, diff and sif will not solve the hidden node problem. What was the solution for the hidden node problem in Wi-Fi? Okay, so there are 2 packets that you have to send before you send your data packet. Well, those 2 packets are called RTS and CTS. Remember, request to transmit and clear to transmit. So if RTS goes through, then we will know that, okay, now I'm going to get it from A, and then it will reject C's request if it also came around the same time, so only one of them will transmit to B. So hidden node problem was solved by RTS CTS combination. So you really sent 4 packets instead of 1 packet. Basically, first you do request to transmit, then you got the clear to transmit, then you send the data, and then you got the data acknowledgement. So that is the solution to the hidden node problem. The other issue is that of the exposed node, and that is the issue where some other nodes, they cannot talk because one node is talking. So if when A talks to B, C cannot talk to D, because if C talks to D, it will be interfered by the transmission from A. And so this is called exposed node, that there are nodes in the vicinity of the network that cannot really get their own service. And so for that, basically we can use directional antennas, so that the energy from A going to B doesn't really go in anywhere close to C or D. And it is and so then there are directional antennas with multiple access with collision avoidance, and there are many proposals for access for media access. Like we said in our slide, there are 10 issues in ad hoc networks, and there are many papers on each of those 10 topics. So similarly, there are many papers on media access control, and MACA is one of them.